Hello everyone, I hope you are all doing well. In this video, we are going to talk about paired sample t-test and see what that is and when we use it. We use this technique when we want to compare two means of two measurements from one sample. It is also called within subject design and repeated measures design. So, here we use the same dataset that we created in the first video, but consider that we did an exercise program on these 12 patients during 2 weeks and then measured their blood sugar level again. So here we define another variable, which is blood sugar level after the program, and we call it after BSL. Notice that this variable is also measured as a scale. So what is important here is that we have the same sample which we have measured twice, once before the program and then after the program, to see whether the program has affected to lower the blood sugar level or not. In statistics, they call the program a treatment. You measure a group of people, then you give them a treatment, and then you measure them again. Then if the scores in second test are higher than a pre-test, you know that the treatment had an effect. So, but how to conduct these tests in SPSS? Here you can see our data set, our new variable, which is after BSL. So go ahead and go to Analyze, Compare Means, Paired Samples t-test. So here, move these variables that you want to compare to paired variables box. So here, move variables that you want to compare to paired variables box. There is something that you should notice, and here there is no difference in the order unless your variables effectiveness are shown by positive and greater results, which it also depends on you. So first put the after variable, then the pre one. But generally there is no difference in different orders, and results will be the same value regardless of being positive or negative. So here we put pre first, then after. And when you're ready, click OK. So as you can see, the first table contains descriptive statistics for each variable. It has means, the sample size, which is 10, and the standard deviation, and the standard error of the mean for each variable. And in second table, we see the correlation coefficient between the two variables. But here we don't need this value, but later when we want to measure the effect size, you'll need this. So, okay, move on to the third table. It contains our inferential statistics, which tells us about the test. So, we see the t-value, the degrees of freedom, and the p-value that corresponds to the t-score 2.397 with 9 degrees of freedom. And also, as you can see, there is the 95% confidence interval. So as before, we have 3 ways to find out if these means are statistically significantly different. First, is the t-value greater than the critical value? So we look up that on students' t-distribution table, and here it is. And you can see with 9 degrees of freedom and 0.05 value of alpha, we have critical value 2.262. And so our t-value of 2.397 is larger than 2.262. So we'll reject the null hypothesis. And the second question, or second way, is that, is the p-value less than 0.05? Here our p-value is 0.04, so which is less than 0.05. And the third way, does the 95% confidence interval cross 0? So as you can see, it doesn't. Both lower and upper values are positive, so they are in the same side of 0, which means that the mean difference is likely to fall 95% of the time between this interval, and it does not cross 0. Therefore, from these 3 findings, we conclude that our variables are statistically significantly different. So, in our research, it means that the exercise program did affect the blood sugar level of patients, and it has reduced it, which means it has affected blood sugar level for the better. And that's how we do paired sample t-test in SPSS. Thank you so much for watching this video. I hope you found this video helpful. In next videos, we'll talk about analysis of variance and its different types and how setting up its tests.